Good day, young mathematicians. Welcome back to my channel. Once again, I am Teacher MatHusay. Today's discussion will focus on factoring general trinomials. But before that, let's have a recall of what have been discussed in my previous video. Perfect square trinomial has three terms, where first and third terms are perfect square, while the second term is positive or negative, twice the square roots of the first and third terms. Remember that any perfect square trinomial in factored form is the square of a binomial a plus or minus b. Examples: 25x squared plus 20xy plus 4y squared, and 9a to the fourth minus 12a squared b plus 4b squared. The factored forms are quantity 5x plus 2y raised to 2 and quantity 3a squared minus 2b raised to 2. Now, try to observe the given trinomials: x squared plus 8x plus 15, m squared minus 5mn minus 14n squared, 6a squared plus 5a minus 6, and 8x squared minus 10xy plus 3y squared. I know that you will agree with me if I say that none of this is a perfect square trinomial, because these trinomials are known to be general trinomials. But will this mean that we cannot factor it? If yes, how are we going to find the factors? Let us have these two trinomials first: x squared plus 8x plus 15 and m squared minus 5mn minus 14n squared. Note that the leading coefficient of each trinomial is 1. Now, how are we going to factor these trinomials? Let's start with x squared plus 8x plus 15. The leading term is x squared, and it is factorable as x times x. How about the last term, 15? Take a look at the diagram at the side. Think of two numbers whose product is 15 and the sum is 8. Very good. The numbers are 5 and 3. Therefore, the factors are x plus 5 and x plus 3. How about m squared minus 5mn minus 14n squared? What are the factors of m squared? Of course, it's m times m. How about negative 14n squared? Take a look at the diagram again at the side. What are two terms when multiplied the product is negative 14n squared and the sum is negative 5n? Correct. The terms are negative 7n and 2n. Thus, the factored form is m minus 7n times m plus 2n. How about this example? 6a squared plus 5a minus 6. Observe that the leading coefficient is not 1. But for us to make use of the strategy in the previous examples, we will remove the leading coefficient 6 and multiply it to the last term, giving us a squared plus 5a minus 36. Then, using the strategy in examples 1 and 2, the numbers that will give us the product of negative 36 and the sum of 5 are 9 and negative 4. Thus, the factors of a squared plus 5a minus 36 are a plus 9 and a minus 4. Now, we will bring back 6 as the leading coefficient of each factor, resulting to 6a plus 9 and 6a minus 4. Next, we need to determine the GCF of each factor. For the first factor, 6a plus 9, the GCF is 3. Dividing each term by 3 will give us 2a plus 3. While for the second factor, 6a minus 4, the GCF is 2. Dividing each term by 2 will give us 3a minus 2. Therefore, the factored form of 6a squared plus 5a minus 6 is 2a plus 3 and 3a minus 2. Let's proceed to example number 4. 8x squared minus 10xy plus 3y squared. Removing the leading coefficient 8 and multiplying it to the third term will give us x squared minus 10xy plus 24y squared. Identifying the factors, we need to identify the terms that will give us a product of 24y squared and a sum of negative 10y. And the terms are negative 6y and negative 4y. Thus, the factors of x squared minus 10xy plus 24y squared are x minus 6y and x minus 4y. Bringing back again 8 as the leading coefficient of each factor will give us 8x minus 6y and 8x minus 4y. For the first factor, there is a GCF of 2. Dividing each by 2 will give us 4x minus 3y. While for the second factor, the GCF is 4. Dividing each term by 4, the answer is 2x minus y. Therefore, the factored form of 8x squared minus 10xy plus 3y squared is 4x minus 3y times 2x minus y. That's it for today. I hope everything is clear. See you in my next video. Thank you for joining me in today's discussion.